All right. So good morning. So now we are moving on to a new topic regarding threat intelligence, right? So threat intelligence is very important because an organization needs to know what are the different threats that might affect its network or infrastructure, and in order for it to know what kind of threats are currently active in the environment for a specific sector or specific nation or specific geographical location, etc., they need to figure out what is going on and what are the indicators for those threats, because threats usually means that attacks are happening. Otherwise, how would I know that there are threats? Of course, I can get some threat information from dark web and telegram groups and other kind of places where chats and various kinds of exploits might be sold in the forums in the dark web and so on, and therefore I might be able to also get some information about various malware that might be going to be used and so on, or what kind of command and control URLs or command and control IP addresses, or what kind of TTPs are going to be used for attacks and so on. So, this kind of information every organization needs to actually get this kind of information on a regular basis, actually on a daily basis, and there are companies which actually collect such information, and they actually then share this kind of information, and when they share this kind of information, they might share this in natural language, right. So, if you send it in natural language, what would happen is that the organization, when they receive that threat intelligence, they have to convert it into a machine readable form, so that this threat intelligence can be fed into various tools. For example, if I know that there are certain command and control URLs or IP addresses, I have to make sure that my firewall has been fed that information, that so firewall can block those IP addresses or URLs and so on. Similarly, if I know that there are certain malware hashes are being seen, then I might want to send that information to all my endpoint detection, or of course the network intrusion detection systems, so that they can look for those hashes. So, making such information machine readable is quite a bit of work, and most organizations may not have the right level of expertise or people to actually convert natural language reports of threats into machine readable form, and that is how this language, this formalized language called STIX, or sharing threat intelligence, has been developed. And currently the version that is going on is STIX 2.1, and what we are going to do is to see what is STIX and what does it look like, what kind of data model does it have, and how to write threat intelligence information in STIX format. And the interesting thing is that not only they have developed STIX, they also have developed a protocol called TAXI. So, the TAXI servers, so TAXI is kind of like a server where the threat intelligence generators, that is companies that develop threat intelligence information, they develop it in the STIX format, and then they put it into the TAXI servers, and its subscribers, so anybody who buys their threat intelligence will automatically communicate with the TAXI servers to actually get the threat intelligence and have the automation to actually have the threat intelligence fed into all its necessary tools like firewalls and intrusion detection system and so on, so that that threat intelligence is then processed and accordingly rules and configurations of those defense protection systems will be updated. So, this is when you go for threat intelligence companies where you buy the threat intelligence. There are also organizations such as CERT, Computer Emergency Response Team, or CERT in India it is CERT-in. There are also sector specific CERTs. For example, there is CERT-fin, which is for financial industry like banks and so on. There could be CERT power. In fact, there are CERT hydro, CERT thermal, and CERT renewable. This kind of CERTs are also there. These are sector specific CERTs. Now, their job is also to generate threat intelligence based on any kind of research they do, any kind of threat intelligence information they receive from other organizations around the world, their peer organizations. Similarly, NCIIPC, the National Critical Information Infrastructure Protection Center, they also share threat intelligence using STIX format. So, even if you do not subscribe to the threat intelligence from expensive threat intelligence companies like Recorded Future, etc., you can Unit 42, etc., but you may still receive threat intelligence for free from CERT-in and other places. So, this is a very common way in which organizations can receive threat intelligence, and just by receiving threat intelligence is not enough. You have to then act on it, and if you use the STIX format, then most tools nowadays like firewall, if you buy a firewall from another company, etc., they actually speak the language of STIX. Therefore, they will be able to automatically process that information and accordingly change their rules or signatures and configuration, etc., as per requirement. So, that is why STIX is very important. There is a STIX is maintained by a group called WASIS group, and they have a website. I will show you where you can find more information for those who are more interested in knowing about how threat intelligence is created and collected. So, the main idea here is that you have to have machine readable threat intelligence, right. So, or what we call MRTI, CTI, cyber threat intelligence, TI, threat intelligence. These terms are very commonly used, and MRTI means machine readable threat intelligence. So, the goal of this whole thing is that since data is transferred in lightning speed, threat is also spreading in lightning speed, and therefore, I have no time to actually tell you in natural language that be careful about this particular URL or IP address or this malware hash or this kind of threat actor, this kind of TTPs are happening, and then you will actually process that information and then act on it. It's going to be too late. So, therefore, the idea is that if you want to make this threat intelligence effective for helping out a lot of organization, then you have to automate the process of sharing threat intelligence, and that is the basic idea behind creating this language. So, MRTI has 3 components. One is STIX. This is the STIX stands for Structured Threat Information Expression. TAXI, it is the Trusted Automated Exchange of Indicator Information, and CyBox is the Cyber Observable Expression. This is rather less, this is in the MITRE, you can find it in the MITRE website. So, we will focus on these two, the STIX and the TAXI. So, TAXI is the protocol for sharing threat information securely between a threat intelligence creator and threat intelligence consumer. Now, STIX aims to get a graphical model, right. So, let me first show you what a STIX model looks like, right. So, here is what we call a STIX visualizer, right. So, STIX visualizer, so here you see that I have let us see sorry. So, I have the STIX file that describes a particular threat, and here are the legends used in this graph. So, here you see that here I have, this is an indicator and this is an indicator. I will explain what indicators are. This is an indicator. Now, this legend is for malware. So, this is a malware, and this legend where you have a person, this is a threat actor, right. And then we have a threat report. So, it is a report and it is a marking definition. So, we will come to all this what these things mean, but you see that here I have a particular threat indicator, a particular type of traffic here. So, I have a particular type of traffic which is an indicator. Here I see C2 traffic, the command and control traffic, probably an URL or something, and then here is an infected host, right. So, what is happening here? Here is a malware, right. So, these indicators, you see that this C2, this, like if you find in your organization traffic going to this command and control server, or if you find this infection, or if you find this particular traffic threshold, like this is a DOS threshold traffic, then you know, see, all of them are pointing to this malware. So, if you find these indicators, you can kind of assume that this is the malware that is in your organization. And then you can also, there is another indicator here which also has to is indicating this. Now, this information is also saying that this particular threat actor, in this case unnamed, is actually uses this malware to do this and this malware can be indicated by these indicators. So, if you see these indicators, you can kind of hypothesize that your system has been infected by this malware, and this malware is associated with this particular threat actor, and here is a report. So, the report is a top level object. Basically what it is saying is that this threat intelligence information is basically reporting. So, it is referring to a particular threat actor, it is referring to a particular malware, it is referring to certain types of indicators. So, this is the overall, this report contains all this information, and marking definition is basically something we will see later, that whenever you share threat intelligence, you may mark it by saying that this can be shared widely, or this can be shared only within the organization, this can be shared only within the sector, this kind of stuff. So, there is a marking associated with this report which basically says who it can be shared with. So, what this tool, this is called the STIX viewer. You can take a STIX file and use this viewer to actually see this graphical representation of this threat information. Now, in some cases this is a very small report, right. It has one threat actor, 4 indicators and 1 malware, right. But in many cases you will have many other elements to this. It can be part of an attack pattern, it may be part of an intrusion set, it may have a campaign associated with it and so on. So, sometimes this picture will be very complex, right. So, this is a simple one, and if you can see that if I select a particular node, for example, if I select this, it is showing me that the structured information has multiple different things, like it has a type. In the type of this object is that it is an indicator, it has an ID. This ID is required to uniquely identify this. Then I have the creation time, I have the creation time, I have the modification time, I have the name, I have some label, and then I have some description. This is a textual description. It says when this indicator is valid from, and then it says which kill chain phases this particular indicator is visible, right. And then it says a pattern. So, this is, since this is an indicator, it has a, this is a basically a URL. So, an URL is an indicator. So, as an URL, this indicator has, I think I am now looking at this one, right. No, this is a different one. This is a Windows registry key, right. So, this registry key will tell you that your host has been infected, right. So, this is a, so this structured description is what you need to write this indicator in a format that is not only machine readable, but it is also unambiguous. That is, the any other tool that is aware of STIX language will be able to process this information and accordingly do the necessary configuration changes, so that it can detect this indicator and so on. So, that is the overall look of this, but what I want to do, I want to teach you the language of STIX for 3 reasons. One is, of course, that you learn that threat intelligence can be actually made machine readable and unambiguous, so that it can be processed by algorithms to change the posture of firewalls and intrusion detector or endpoint agents and so on, so that they can be better at, they can be more current on the threats that they might be fighting, right. So, otherwise they will be they have to be see the other way would be to hard code the indicators inside your tools, right. So, for example, you can say, okay, I will put all the firewall rules in the beginning, and then if I have to change any rule, then I have to bring it down and then restart it, right. Change the new rules, put the new rules and then restart it, but that is not practical, because you cannot take down the protection software and it, and so you have to actually dynamically be able to process this kind of information and change the posture of that software or equipment to actually do better at fighting the threats that are new, that are coming as threat intelligence in real time. So, that is the idea. So, that is one reason why STIX is an important concept that everybody needs to know if they are going to be in charge of protecting your infrastructure. Plus, you can get STIX information not only from vendors who are going to charge you money for subscription to their taxi service, but also you can subscribe to the taxi servers of CERT and sector specific certs and ISACs and various other voluntary organizations or government regulatory organizations who share threat information. The second thing is that you get to know that this kind of language, this structured language has a very important role in all of software engineering, including cyber security tools, right. Because nowadays you will see that even configuration files are created using structured JSON using JSON syntax basically, right. So, in this case also it is a JSON syntax that is being stylized for this specific purpose to create the language for STIX, right. So, it is basically a data model, and then the third reason is, of course, that I want to give you a homework in which you have to take a threat report and write the corresponding STIX, right. So, that is the third reason why you are doing this, right. So, now here is your different types of objects, right. So, we already saw this picture, right. So, like we have an indicator which indicates something, this is like it may indicate a presence of a threat actor, it may indicate the presence of a campaign, an attack campaign, and this campaign may be attributed to a threat actor, like for example APT28 for example, and then you can also say what vulnerabilities it is targeting, right. So, there are various types of objects. For example, here you see you have a indicator object, you have a threat actor object, you have a campaign object, you have a vulnerability object and so on, right. So, these are different types of objects and each object can be described in a certain fashion, right, with certain attributes. So, now this components of STIX model, first thing is called STIX domain objects. So, we will see what these domain objects are. For example, campaign is a domain object, indicator is a domain object, threat actor is a domain object. So, these are specific type of objects. There is also another object called cyber observables, anything that you can observe, like for example, a file or an URL or something or an email, a message, etc. These are cyber observables. And then you have relationship objects. Relationship objects usually relates the domain objects to the cyber observables, or maybe it can also relate to domain objects or to I guess observable objects. There is also a extension definition object. This is for, because this is kind of object oriented. So, there is a derivation process by which you can extend an object. So, that is there. There is also meta object and bundle, that is when all the objects for a specific threat intelligence has been created, you put them in a bundle. So, there are some meta objects and bundle is the top level object. And then there is a patterning language, like if you like regular expression is like a patterning language. So, this is a little more than regular expression. So, there is a patterning language. So, these are 6 components of the STIX 2.1 data model. So, what we are going to do now is to actually look at the various domain objects, because they are the most important part of the STIX data model. And this domain objects I am describing in the order of alphabetical order. So, there is not, it is not like I am talking about attack pattern object first, means that attack pattern object is the most important object, nothing like that. I am just going through, I basically took this from the manual, and the manual basically goes through all these object descriptions in an alphabetic order. So, attack pattern, right. So, example of an attack pattern is spear phishing, right. So, spear phishing is an attack pattern, or it may be a DDoS may be an attack pattern. So, when you might describe an attack pattern, right. So, you can say attack pattern is a type of TTP that describes a way a threat actor attempt to compromise targets. So, I want to capture what is it that this particular threat actor does. So, I can describe that as an attack pattern object. Attack pattern is used to help categorize attacks, generalize specific attacks to patterns that they follow, and provide detailed information about how attacks are performed. So, we will see an example. So, spear phishing would be an attack pattern, but you can also have more specific attack patterns. For example, a spear phishing as a practiced by a particular threat actor, right. For example, they use a like maybe a particular threat actor always uses a lottery winning type of phishing message. So, that could be a more specific attack pattern if I want to be more specific. So, here is what the attack pattern object requires. So, if I want to describe an attack pattern, I can describe the attack pattern with these attributes, right. So, attributes, what is happening? So, I have to see, I have to tell the values of this attributes, right. So, those of you who know JSON, in JSON I can basically write this colon the type, a string that basically describes its type, spec version, you can say for example colon the string that describes the spec version, in this case this is STIX 2.1, the ID of the attack pattern, the ID has to be a unique string identifying this attack pattern object. Why? Because if I in a relationship object, if I want to describe that this attack pattern is used by so and so threat actor, there is also a threat actor data object. So, I have a threat actor data object and I have the attack pattern data object, I have to relate the two. So, I need this unique ID for this attack pattern to do that relationship. These are information like when was this object created, if it has been modified since, those things. R here means that it is required. So, if I want to create an attack pattern object, I must fill in these attributes and these attributes, it have to give it a name, right. Other ones are optional. For example, created by, revoked, whether it has been revoked, labels, confidence with which this attack pattern is being put out as a threat intelligence information, language associated with this attack pattern, some external references, it might give you additional documentation references by using an URL, object marking references. This is about as I said that about marking has many different usage, but in this case it may be about who it can be shared with, how widely it can be shared. There may be more granular marking, and there may be an extension in case there will be a derivation from hierarchical derivation from this object. And then here you can give a description as a string, you can give some aliases for this attack pattern, and then you can also describe the kill list the kill chain phases in which this attack pattern is using, right. So, all this information can be put into a JSON format. Yes. Yeah. At least locally unique, right. Global so you cannot do, right. So, but locally at least it has to be unique. Correct in what sense? No, so the taxi server is actually have authentication, encryption and all that stuff. Now, integrity of this STIX files from the threat intelligence company is their responsibility. So, you cannot guarantee this here, because they might keep a hash of the every file and continue to check and all that stuff, but that is their responsibility. For you it is difficult to check, I mean you will not be able to check whether it has been tampered with since its creation. Yeah. No, so two companies might give you see if they created their own threat, they might also have derived it from the, let us say CERT, US CERT, right. In that case they may have same ID and all that stuff, but in case they have actually created on their own, it is unlikely that IDs will match, right. In fact, if to you, let us say two companies, you have subscribed to two companies and they are actually describing the same attack pattern, but you will not know that they are the same attack pattern, you will treat this as two separate threat intelligence. Later on now this by itself the attack pattern is not very useful, right. What will happen is that this attack pattern will be related to some indicator objects. See, only way you can use the threat intelligence in your system, in your organization, is through the indicators. See, if you see that indicators could be a CNC URL, it could be a malware, it could be a registry change, it could be a particular type of file or hash value, etc. These are indicators, right. So, let us say one company is saying that when you see these indicators, that is associated with this attack pattern, and this attack pattern is associated with threat actor, let us say APT28, right. You go to another company, let us say Microsoft, from which you again got a STIX, and you saw some indicators, and then using that threat intelligence, you will see that if you see the same indicators, you will relate that to a particular attack pattern ID which is associated with fancy bear, right. Now, fancy bear and APT28 are the same, right, is considered to be the same. So, later on that part you have to do manually, right. So, when you are interpreting, when you are catching a particular attack pattern in your system, obviously you are not then are doing automation, you are then in the incidence response phase, right. At that point when you see, okay, I have threat intelligence that is telling me that I have indicators of fancy bear and I also have indicators of APT28, then I will see whether they are the same or I am now being attacked by two different threat actors. And at that point you will consult Google or whatever or companies that will help you out, and they will say, "Arey, this is the same." But at the same point in time, you may be attacked by two different threat actors as well, right. So the idea is that all this all the threat intelligence is doing is increasing your capability to associate indicators to particular threat actor or particular attack pattern, and then rest activity, that is incident response activity, is separate, that this thing does not help. This thing only helps you use the indicators and know what indicators to look for, because indicators continue to evolve, right. Like today you have some indicators, some C2C, same threat actor may actually next week change their C2C IP addresses, right, which they do. So, unless you are subscribing to a feed like this, you will not know that, right. So, in that case you will see a traffic to a different IP address and you will say, okay, this is not in my threat intelligence, so I am not going to do anything about it. That to avoid that, I need to have continuous updation of threat intelligence. So, then the next SDO is campaign SDO. So, campaign SDO is basically is a grouping of adversarial behaviors that describes malicious activities or attacks, sometimes called waves, that occur over a period against a specific set of targets. Now, campaigns usually are part of what is called an intrusion set. So, let us say APT28, right. So, APT28 did a campaign during the COVID time by using a supply chain attack on SolarWind, right. So, all of us remember SolarWind attack. So, that was APT28, but APT28 also does many other attacks, right. So, APT28 is not just doing that SolarWind attack. So, if I want to have threat intelligence about APT28, I may describe an attack pattern that APT28 is using for the SolarWind attack. In that case, it was a supply chain compromise, right, and they used a specific malware. Tomorrow, APT28 is using a different set of malware and different C2 infrastructure. So, and different attack pattern, they might be doing a spear phishing as well, right. So, I have multiple attack patterns associated with APT28, but also I have different campaigns associated with. So, SolarWind campaign is different from another campaign done by APT28, and there are probably hundreds of campaigns of APT28, including on the during the Ukraine war, right. So, I will describe each of these campaigns separately. Then all these campaigns may come as part of what we call an intrusion set object. Intrusion set contains multiple different campaigns, which is now associated with APT28. So, APT28 will now be associated with an intrusion set which contains multiple campaigns, and each campaign may contain multiple attack patterns, and each attack pattern may contain multiple indicators, right. So, this is how the entire thing is. So, now you might say that what good is it, because all I need is indicators, right. Why do I need to know whether these indicators are part of a particular attack pattern or particular campaign or intrusion set? I might as well just get the indicators and I just stop banning those indicators. So, if I see a particular C2 traffic which I know is an indicator for certain APT, I will just ban that traffic and if I see a particular malware, I will quarantine that malware. If I see a particular IP address, I will stop that IP address and so on. The reason is that eventually you need visibility about what is happening in your system, right. The indicators, suppose you only know the indicators, right, and you are being attacked by some group of thugs sitting in Noida versus APT28, right. You want to know that the indicators I am seeing, I know it is an attack, right. I am going to stop those IP addresses and so on, but I also want to know what is the situation with respect to me, right. I mean, am I being targeted by some not so sophisticated thugs sitting in some place, Noida or some place, or am I being attacked by the most resourceful attacker in the world, one of the most resourceful attackers in the world, APT28, right. So, I need additional information, not because that will help me automate. So only thing that helps me automate is the indicators mostly, right. But this additional information enriches my incident response capabilities and my ability to understand, respond and recover, right, and communicate. For example, if I am getting attacked by APT28, I should be very careful, because that means that I am in the target, for some reason my business is in the target of a nation state attacker, right, versus if my business is a target of a regular cyber criminal, right. So that is why this enriched information of threat intelligence will help me to actually know what is going on inside my system, and that is why this attack pattern, campaign, etc. are useful. So campaigns can be characterized by their objectives and incidents they cause, people, resources they target, etc. So for example, this is 2016 Acme Bank. So a particular crime syndicate used particular C2 servers and a specific malware to attack Acme Bank during 2016 summer, and the objective was not to get money or something, they were trying to get secret information about an upcoming merger with another bank, so that they can do insider trading, right. So that was a campaign, right, that was a specific campaign. So now here is what it looks like. So here is a campaign, this is a spec version, ID, you see the ID, to make the ID unique there is a randomized string generation. Usually if you have a software that helps you, software editor for STIX creation, that will help you to do these unique IDs. Creation date, modification date, etc. Name, and this particular campaign has been named admin at 338. So this is a Chinese threat actor, and it is there is a description which is optional, where it says what it is. First seen is date, last seen date is not there, objective is not there, but you can put this additional information if you have them, right, but these are ones you have to provide. So when this threat intelligence comes, so campaign by itself will not come to you, right. So campaign will come with corresponding attack pattern, corresponding threat actor, corresponding indicators, all that stuff, right. So this is, I am just showing you a fragment of a STIX file. So nobody is going to send you a campaign SDO as threat intelligence without any indicator or anything, right, because it is not going to be useful for you if you just get this. So now there is another SDO called course of action. The course of action SDO is thought of as a way to provide automation for what to do when an indicator is seen, right. But right now in the current version, it does not have the capability to provide automation instructions. So it only provides prose information about what course of action to take when you see a particular campaign or when you see a particular attack pattern or something. So you can give a textual description of what course of action to take when you see something, but in the future it is supposed to be containing instruction for automatable responses like applying patches, reconfiguring firewalls, etc. Right. So right now the firewall company has the responsibility to automate. So when it gets a STIX file, it automates certain things, or if it wants to automatically block or something, it is the firewall company that will give that as a feature. This is not part of the language. The language does not say anything about what the firewall company should do. So every firewall company will do different things, right, as a response to finding a particular indicator. So it is a textual description of action. So it is a reserved action property, also serves as a placeholder for future inclusion of machine automatable courses of action. So courses of action, here is a SDO that has a course of action type, ID created by creation date, modification date, name. It says analyze with FireEye calamine tool set. See, it is not giving you a script to do so, it is just saying so. So eventually your intrusion detection system might, when this course of action will be associated with a particular indicator, your intrusion detection system might flash to you that this is what you should do, right. That depends on the intrusion detection tool vendor. And then it is giving a description that calamine is a set of free tools to help organizations detect and examine poison ivy infection in the system. So this is a particular malware. The package includes those components, these components, PIV, callback decoding tool and memory decoding tool, etc. So you can, and the source name is external reference. So this is additional information. So this is in the future, probably this particular one will be very useful. Right now it is just additional information, and your tools, the intrusion detection tools, etc., might be able to use it in some way to help you as a help message or something, but it is not going to automate anything. Now grouping SDO is the how you group different objects. So this is so we already saw multiple objects, right. So we saw this object like course of action object, we saw an example of a campaign object, we saw example of well, I haven't seen any other, but so while you are actually creating threat intelligence, so I am a threat intelligence company and I am a threat analyst, and I am creating this threat intelligence information which I will sell to my subscribers, right, or I am certain, in that case I am not selling, but I am going to, I have a pressure on me to share threat intelligence as soon as possible with all constituents, because they have to be protected against these particular campaign and so on. And I got the threat intelligence information. So I first look at indicators. So I create some indicator objects, right. So I create the JSON structures saying that this is a malware, this is a URL, this is a registry key change, all that stuff. These are the things that are going to be seen as part of this threat intelligence. Also I suspect that this is this threat actor, and also I suspect that this is based on this attack pattern. So I am writing multiple SDO object, right. Now I want to also, I am going to work with another analyst who is also going to help me to add additional, because this is time consuming activity to create correct STIX objects, right. So what I do is I create a group. So I put it in a grouping object. The grouping object basically groups related objects which are related to a particular campaign, particular threat actor, whatever, and this is kind of not useful for doing any protection or anything. This is useful while creating the threat intelligence, because I basically shared the group with another person, so he can enrich it by adding additional objects inside it, right. So, that is what grouping object is. So, grouping is not so important, but you will see a lot of grouping there. So, grouping has all these things: type, spec, version, ID, created, modified, and there should be a context. So, there should be a shared context and some object references, the objects that are grouped together, that their references by their IDs should be there. So, this, when we actually look at multiple examples of STIX, you will see a lot of grouping, right. So, grouping is something that is more for convenience of sharing the responsibility of creating a shared STIX file. Identity SDO is identity is important for any threat intelligence. For example, I might want to say that this threat intelligence pertains to this particular sector, power sector or finance sector, or I might want to say that this group, like the Reliance group, has been targeted with this particular organization, or educational institutes are being targeted by this particular threat actor. So, I may want to add identity information. So, identifying information, contact information, and sectors the identity belongs to, and they are used among other things as target of attacks, information sources, object creators, threat actor identities, and so on. So, here is an example. FireEye, as you know, is a threat intelligence company. So, it's an identity, it's an organization, its sector is technology, and this is the information. Now, why have I created this? Because later on in my larger STIX file, I might say what is the source of this information, right. Source of this information may be FireEye. So, at that case, I will use this ID to associate the top level object, the bundle for example, or the report object to this identity. So, this identity is useful to give that kind of information. And again, this information is not going to help me protect myself as such, because as I again and again said, that only thing that protects me is the indicator information, right. Everything else is additional information. However, in my tools, let us say I have a SOC, and in the SOC I am showing in that I am right now having an incident happening. How do I know an incident happening? Because I am seeing the indicators that my threat intelligence is telling that if you see this URL traffic and if you see this malware, etc., then you know that you are being attacked by this kind of a campaign. Now, when I am showing this to SOC analyst, that look, there is an incident in progress, and because I am seeing these indicators, I also may want to tell him that this information comes from FireEye, right. So, that he knows where this information coming from. Who is telling that these indicators are indicative of some kind of a problem. So, therefore, this kind of information is additional enrichment of the threat intelligence information. The incident object is again a stub, it does not have much, it is included to support use cases, right. So, what constitutes an incident, right. So, if you see these indicators, can you say that right now I should treat this as an incident? So, that is what this incident SDO says. So, it has all these things, it has a name, but it may also have other things like which sector this incident is from, contact information, and so on, right. So, now this is the most important one, this is the indicator SDO, but I have run out of time. So, I am going to stop here, but what I would like to do is to discuss this in an extra class on Monday evening. I'll email you. I'd like to see if I can get a room where we can do this, because this is going to take some time. I am like I am on slide 16 out of 101 slides. So I have to get some additional classes, but but you do not have to memorize everything that we are saying here, right. You get the basic concepts. What is this STIX for? What are the different types of STIX objects, and what are those objects used for? You do not have to know like what are the attributes of each STIX object and so on, right. So that is what is important. So you do not get intimidated by the number of slides. It is not the concept is pretty simple, right. Okay, all right.